This section is entitled Equations Containing Two Variables, and we're really going to look at how we can use an equation to generate ordered pairs. So where we're going to start is by determining whether an ordered pair is a solution to an equation. Then we're going to create our own ordered pair solutions of equations by knowing what one is and finding the other. Then we're going to use that concept to construct a table of solutions and then graph equations using that table of solutions. So, we've previously solved equations in one variable. If we knew x minus 4 equaled 3, we would know we can add 4 to both sides and end with an answer x equals 7. Basically, when there's only one variable in the equation, we can take numbers to one side, keep letters on the other, and solve for one of that variable. To show that yes, 7 is the correct answer here, we could plug the 7 back in for x. 7 minus 4 would give me 3, and we'd be left with the true statement, 3 equals 3. If by plugging in one of the numbers where the variable is gets me back to a true statement, then I found the solution to that equation. So we're going to extend this idea to now having two variables, where if we plug in both numbers, do we get a true statement? So let's consider y equals x minus 1. A solution of y equals x minus 1 is a pair of values, one for x and one for y, that make it true. So here they show us that if we put in 5 for x and 4 for y, we start with y equals x minus 1, we put in 4 where we used to have a y, we put in 5 where we used to have an x. Because 5 minus 1 does equal 4, we end with a true statement, which basically has proved that the ordered pair 5, 4 is a solution to y equals x minus 1. So another way of saying it is that 5, 4 satisfies the equation. In general, a solution of an equation in two variables is an ordered pair of numbers that makes the equation a true statement. Is the ordered pair -1, -3 a solution of y equals x minus 1? To figure this out, we're going to plug in where we see the x, -1, because it's the first number in our ordered pair. We're going to plug in wherever we see y, -3, because it's the second number in our ordered pair. Remember, we're always given them as x, y in parentheses. So when we substitute these in to y equals x minus 1, we're left with -3 equals -1 minus 1. Since we have two negatives on this side, -1 minus 1 combines to give me -2. So we wind up with -3 equals -2. But that's not true. -3 does not equal -2. For that reason, we get a false statement here, which means this ordered pair is not a solution of this equation. If we plugged in and gotten something like -2 equals -2, then it would have been a true statement, and we could say, yes, this satisfies the equation. But in this case, this ordered pair did not satisfy the equation. It is not a solution. If we only know one of the values in an ordered pair solution, we can find the other one by plugging into the equation. So if, for instance, we know -4 something is a correct solution to y equals -x plus 2, here they've given us the x-coordinate, and we just need to plug in to find the y-coordinate. So we're going to substitute the x-coordinate in wherever we see an x. So we're going to put in -4 wherever we see an x in the equation. Y equals -x plus 2 becomes y equals -4 plus 2. I always like to put those parentheses around something I'm substituting in, even when it's not really necessary, just because I'll remember those parentheses when it is necessary, like it is here. Without those parentheses, you might accidentally think there's just one negative side. By putting in for x the parentheses around the -4, you see it's a negative and a negative. When we multiply a negative times a negative like that, it makes it a positive 4. So then it becomes 4 plus 2, which gives us an answer of 6. When we plugged in the x-coordinate of -4, we got an answer or y-coordinate of 6. That means the ordered pair that we got is when we put in -4 for x, we get back 6 for y. We can use this general idea to construct a table of solutions. Basically, if we're given something like y equals x minus 1, we can just choose any number of x values, plug those values into the equation to get the resulting y, and it'll give us a series of points, all of which satisfy the equation. So in the end, we'll have ordered pairs that are correct solutions to the equation. This is showing why -4, -5 would work for our y equals x minus 1. So we can put in our table of solutions, the x-coordinate is -4, the y-coordinate is -5, and as an ordered pair, it would be parentheses, -4, comma, -5, and parentheses. Using that same method, we can plug in -2 for x and get back a y of -3, meaning we now have a second point, -2, -3, that also is a solution to this equation. Next thing they do is plug in 0 for x. I would say in general, this is definitely a good starting place. If you're allowed to just pick whatever you want for x in order to find an ordered pair, I highly recommend throwing in 0 because that should be the easiest thing to solve. In this case, when they put in 0, they get -1, so they get the point x equals 0, y equals -1, versus an ordered pair 0, comma, -1. Here they do a forced solution, they put in 2 and get back 1, so now they have a complete table where for y equals x minus 1, they have 4 possible x values, which lead to 4 possible y values, and give you 4 ordered pairs as a result, all of which satisfy the original equation. Here they do one more, 4 and 3 also satisfies, so now they have a 5th solution to the equation. Since we get to choose whatever we want for x, all of these are valid. They have found 5 valid solutions. I could plot all these points if I like on the coordinate plane, and then they would connect into the line y equals x minus 1. That's really what we're doing in this last section. We're saying if we have these points, can we put them on the coordinate plane the way we did in the last lesson? Here they are laid out. You can see that you could connect a line that would go straight through all these points. So we haven't had to use y equals mx plus b, some other things that are coming up later in this unit. All that we've done so far is recognize how to plug in one variable into an equation to get an answer for the next variable. So basically we're putting in the independent variable x to get back the dependent variable y, and putting it in the form of an ordered pair. If we can create this list of ordered pairs, we can then put them on the graph and connect them with a line. So this is showing how it would look when we connect it with a line. I will warn you that in the online homework it asks you to draw these lines with a graphing tool, which sometimes gives students problems because it doesn't come up the way they'd like on their system. You need to download a Flash player and make sure it's active. If it's giving you complete problems where you can't see it, if it's just you're having trouble using the tool, feel free to email me. But basically, you fix one point and then you use the line to show what direction it goes from there. So hopefully, if you try and mess with it a little bit, it'll become easy to use, but definitely there are students who the first time through get a little confused with the line drawing tool in the system. Again, please email me if you have any questions. So the arrowheads just show that the line goes on forever. So really, I'm only seeing from -5 to 5 in the x direction, from -6 to 4 in the y direction, but if I kept on going, this line would keep on going. So by putting the little arrows at the end, it's just showing it's not a line segment that stops on the part that we're seeing. It goes on forever in both directions. Summarize what we've seen here. To graph an equation x and y, we follow these steps. First, we make a table of solutions by plugging in specific x values to get back the associated y values. We then take each of the points that are created, plot them on a coordinate plane, and we draw a line through those points. Since we usually choose a number for x and then find the corresponding value of y depends on x, meaning x is my independent variable, y is my dependent variable. The value of the independent variable can also be called the input. The dependent variable can also be called the output. So if we just start off with the question, graph y equals -2x minus 2. First step, we need to pick some numbers to put in for x and get back y values as ordered pairs. So here, we're going to start by plugging in -3. When we put in -3, it gives us an answer of 4. So we have -3, 4 as our first ordered pair. If we continued in this way, putting in -2, -1, 0, and 1, our equation would solve and we would get 2, 0, -2, and 4. We can then organize this information to x, y ordered pairs and graph them here on the axis. Once we've graphed them, -3, 4, -2, 2, -1, 0, 0, -2, 1, -4, we can then connect them in a line, which shows us the graphed line, y equals -2x minus 2, which was our original goal. So again, our steps were we started by picking these numbers to plug in. We then solved what's the resulting y, which allowed us to list ordered pairs. After we had the list of ordered pairs, we graphed them and connected them into a line.